I give you something like this. All right. I want to ask you something about vertical asymptotes because it's been a while since you did those. Now, we're supposed to already know how to do this, but let's just double check. How do you check for vertical asymptotes? Remind me. Set the denominator equal to 0. So x plus 1 is 0 says x is a what? -1. Now, is that for sure a vertical asymptote? No, that's a candidate. How do I find out if that's for sure one? What has to be true? When I plug it in, right, I can write, I have to get 0 on the bottom and not get 0 on the top. Does that happen up here? Don't I get -3 over 0? So I'm going to have a vertical asymptote x equals what? -1. So we already know how to do vertical asymptotes. Now let me ask you this. What if it had been x squared plus 1 instead? We'd have had x squared plus 1, which said x squared is a -1. What would that tell me? This thing doesn't have any what? Vertical asymptotes. Because you can't square a number and it'd be negative in the real number system. So if that had been the case, I would have put no vertical asymptotes, and this would have been my work to defend it. We okay? So we're already supposed to know how to find vertical asymptotes. Now, horizontal asymptotes are a little more fun. All right. So in your book, they show you some on page 239. They want to make sure that you're clear about something. Suppose you have this graph. Suppose this was y equals 1. And you had a graph that went like that. So do you understand, as x gets bigger and bigger and bigger, what's y getting closer and closer to? 1. Is it ever going to touch 1? No. So this dotted line, y equals 1, wouldn't be a vertical asymptote, it would be a what? Horizontal asymptote. Now, it could be, because this happens sometimes, we'll kind of look at one in a minute. Sometimes you get a graph that does something like this. So suppose this is y equals -1. So do you understand on this f of x, on this red f of x, the limit of f of x as x approaches infinity? Now, we've not had this before. We've had infinity for answers, but we've always been approaching a number. So all this is saying is that x is getting bigger and bigger and bigger with no bound, with no cap. I used to have a senior professor who would just have a freak out if I said x approaches infinity. You can say that, I'm not going to freak out. But he was right. He said that you should say x increases without a bound. You can't approach something that's not a number. And infinity is not a number. Infinity is an idea. Okay? But on this graph, you understand, as x gets bigger and bigger and bigger, isn't y closing in on something? What's y getting closer to? 1. And on this particular graph, what happens when I'm approaching negative infinity? What if I'm going to the left and it's getting smaller and smaller without a bound? I get a -1. So do we understand? That's how you know you're going to have a horizontal asymptote. When you're going to have a horizontal asymptote is when you're approaching infinity or negative infinity, and you're getting a number answer. That's when you're going to have horizontal asymptote. Now, look at something that's different than that. What if you had y equals x squared? Just your parabola. All right, so your f of x is just x squared. What happens when x gets bigger? What happens when you square bigger numbers? What do they get? Bigger. So when you take the limit of x squared of this function as x approaches infinity, you get a what? An infinity. And as a matter of fact, if you're approaching negative infinity, you'd still get a what? A positive infinity, because when you're going to the right, your y values are getting bigger and bigger. And when you go to the left, your y values are getting what? Bigger and bigger. Do you have any kind of horizontal asymptote on this picture? No. When you approach infinity or negative infinity, you get an infinity answer, you don't have a horizontal asymptote. So the way you're going to know whether you have a horizontal asymptote or not is you're going to approach infinity and negative infinity. If you get a number answer, then y equals that number is your horizontal asymptote. If you don't get a number answer, then you don't have a horizontal asymptote. Okay? So let's kind of write these steps down in your notes and then go use some. And there's kind of a little, let's call it a technique instead of a trick. Okay. So the way you're going to check is you're going to find the limit as x approaches infinity, and I'm going to put positive or negative there because we're going to try it both ways of your function. Okay. Now, I'm going to put up kind of a parenthesis here in a second. If you get a number answer, then y equals that number is a horizontal asymptote. Okay. If you get an infinity, like a positive infinity or negative infinity, if you get any kind of infinity answer, then you do not have a horizontal asymptote. Now, let's see if this makes sense. Y equals 1 over x. Now, you graphed these probably in high school. First of all, does that have a vertical asymptote? Yes. Yeah. What's the vertical asymptote on this graph going to be? X equals what? 0. What's that the same thing as? What's x equals 0 is another way of saying it. Isn't that just your y-axis? So this y-axis is going to be a vertical asymptote. Now, what if you got like 1? What's 1 divided by 1 going to give me? 1. So 1 1's on this graph. What if you got 2? What's y going to be? 1/2. If you got 3, you'd have what? 1/3, wouldn't you? Now, what if it was 1/2? What's 1 divided by 1/2? It's 2, isn't it? Isn't 1 divided by 1/2 the same thing as 1 times 2? So at 1/2, this thing jumps up to 2. At 1/3, it's going to jump up to what? To 3. So do you understand that you get this picture? Now, is that all the graph or just part of the graph? That's just part of the graph, isn't it? What if you had a -1? What's 1 divided by -1? -1. If you had a -2, would you have a -1/2? A -1/3. If you had a -1/2, wouldn't you have a -2? You get the hyperbole, aren't you? And you graphed that before. So what happens when x gets bigger? What's the limit of 1/x as x gets bigger and bigger and bigger? 1/10, 0.1. 1/100, 0.01. 1/1000, 0.001. What's this thing getting bigger, closer to? 0. Now, what if you were approaching negative infinity? Wouldn't it be getting close to 0 but from the other side? If x is -10, you'd have a -0.1. If x was -100, you'd have a -0.01. And notice, isn't y equals 0? Isn't this the horizontal axis? I'm getting closer to 0 from this side, and I'm getting closer to 0 what? From that side. Let me ask you this. What if it were Everybody with me? What would the limit of that function be as you approach infinity? Does it really matter what that numerator is if it's a number? No, if I've got a constant over a denominator and the denominator is getting bigger and bigger and bigger, what's that fraction going to go to every time? Because eventually, wouldn't this be like a quadrillion on the bottom, and that 10 million is just now dwarfed by that thing? So does it make sense to you that they put this in your book? All right. So if you look on page 240 in your book, they write it like this. Now, they put C for constant. So there's a number on the top. Now, what if this were x squared instead? Wouldn't that just get to 0 faster? So if you've got a constant on the top, and you've got x to a positive power, and x is getting bigger and bigger and bigger, what's this thing always going to go to? 0. And they remind you that if this were negative infinity, it'd still go to 0. It just go to 0 from the other side. Does that make sense to everybody? So it doesn't matter how big this top number is. Eventually, if this thing's going to infinity, I mean, that's going to get dwarfed by this bottom number eventually, no matter how big the top number is. Now, what's going to happen is this. This isn't hard when they give you something like a constant over this. You can see that pretty clearly. When things start getting a little iffy is when they give you problems like this. Or Now, do we understand that if I went to all of these and I ask you about the limits? Now, if x is getting bigger and bigger, what's 2x getting? Isn't it getting bigger? What happens when you add 1? It's getting what? A little bit bigger. So do you understand when x approaches infinity, that top's going to infinity? What's happening to that bottom? It's going to infinity. Isn't that true on all of these? On all of these, you're getting like an infinity over another infinity if you just start thinking about the top separately from the bottom. The top's getting bigger and the bottom's getting bigger. The question is, who's getting bigger faster? What if the bottom's getting bigger way faster than the top is? What's happening to the fraction then? Is it getting bigger or smaller? If the bottom's getting bigger way faster than the top, it's getting smaller. What's happening to the fraction when the top's getting bigger way faster than the bottom? Now the fraction's getting what? Bigger and bigger and what? Bigger. What if the top is always getting faster, about twice as fast as the bottom? Well, if it's always about twice as fast, that means that thing ends up being about 2 every time, doesn't it? So sometimes when you got one that's a constant, it's easy to think about it in your head. But when you start having infinities on the top and infinities on the bottom, then it gets to be a little stickier. Caroline?
Maybe making this up, but for some reason it's in my brain. But can't you look at that first one and be like, it's approaching 2 fifths? Or did I make that up?
No, we're going to talk about one.
Oh, okay.
Now, there's a little technique that they tell you to use that's helpful sometimes. When you got an infinity kind of over another infinity, when the top's getting bigger and the bottom's getting bigger. What you're going to do is this, and this is what I want you to go back over here and kind of write down. So back over there on step 1, I want you to write this side note. If you have a rational function, now do we know what a rational function is? That's a polynomial on top of another polynomial. The trick or the technique is to divide every term by the variable raised to the highest power in the denominator. That's going to help you take that limit. And you write that down and I'll show you what I mean. We've got y equals 2x plus 1 over 5x minus 3. And they ask me, does that graph have any horizontal asymptotes? Well, step 1 said to take the limit as x approaches infinity or negative infinity of that graph. So do we agree that that top's going to get bigger and bigger and that bottom's going to get bigger? All right, what's the highest power of x on the bottom that you have? X to the what? First. Then everything is going to get divided by x to the first. I mean, isn't that legit? If you had 10 15s, you could take 10 and divide by 5, and you could take 15 and divide by 5, and you're still going to get an equivalent thing. So when you got a fraction, you can divide the numerator and denominator by the same number, and this fraction is equivalent to that fraction. So that's how I know that this fraction is equivalent to what? To that fraction. Okay, I'm not just doing something that's illegal mathematical. Now, let's clean it up a little bit. So we're back to limits on test 1 for a minute. Well, first of all, what's 2x divided by x? That cleans up into a what? 2 and 2. 1 over x won't simplify. 5x divided by x cleans up into a 5, and then 3 over x will not simplify. Now let's go back in our minds to the very beginning where we're doing limits. Now I'm going to write out a lot more steps that you have to write out later, but I want them in your notes. Okay? The limit of a fraction, we had a rule that said that that's the limit of the numerator divided by the limit of that denominator. Remember, I told you that sometimes those shortcut rules weren't going to help. There would be times we had to go back and use the longer rules. And then we had another rule that said if you have the limit of a sum or difference, you could do the sum or difference of the limit. So I can separate them. So that's going to be the limit of 2 as x approaches infinity, minus the limit of 1 over x as x approaches infinity. And then I've got the limit of 5 as x approaches infinity. And I've got the limit of 3 over x as x approaches infinity. So this is all from test 1. Back to limits. Now, you can't get limits confused with derivatives. What's the limit of a constant? It's the constant. Now, what happens when this bottom gets bigger and bigger, like 1 over 10 and 1 over 100 and 1 over 1,000,000? What's the answer to this limit right here? Everybody say that's 0? Again, what's the limit of 5? No matter what you're approaching, is just what? 5. And then the same thing, if that bottom's getting bigger and bigger, 3/10, 300, 3,000, 3,000,000, this limit's going to what? 0. So my answer comes out to be 2 what? Isn't that a number? So I have a horizontal asymptote. At y equals that number. Y equals 2/5 is going to give me a horizontal asymptote on my graph.
Just back at the top, wasn't that supposed to be a plus sign instead of?
Where, yeah, it does need to be. Thank you so much. It does need to be a plus sign. Yeah. Okay. All right, is everybody okay on that one? Then I want you to go do this one. I want you to check for horizontal asymptotes on this one. A 2x squared plus 1 over a 5x minus 3. So I'm changing the graph. Does this one have a horizontal asymptote? So 2x squared plus 1 on top of 5x minus 3. All right, what's the highest power on the denominator? x to the what again? To the first. So everything is divided by x to the first. So it's not the highest power in the whole fraction, it's the highest power in the denominator. So you understand how I decided to divide by x. All right, then I cleaned it up a little bit. So 2x squared over x, what's that simplify into? 2x. 1 over x won't simplify. That gives me a 5 minus a 3 over an x. Now, rather than writing out each part, do you understand what the limit of each one of these separately? Now, I'm going to skip for a second just to make something clear. What happens to this right here, this one right here, when that bottom's getting bigger and bigger? What's 1 over x do? Everybody understand what we're talking about? Your y is 1 over x, so that'd be 1 over 10, that'd be 0.1. If x was 100, you'd have 1 over 100, which would be 0.01. If x is 1,000, you've got 1 over 1,000, which is 0.001. What are these y values doing? They're getting smaller and smaller, so what's the limit of that one? That's going to be 0. What's the limit of a constant 5, no matter what you're approaching? 5. Do you understand that 3 over x, when x is getting bigger on the bottom, is still going to be what? 0. Everybody clear? But what's happening to this 2x? When x is getting bigger and bigger, what's 2x doing? Isn't it getting bigger? So when you're taking these bigger numbers and dividing by 5, in the answer getting bigger more slowly. But it's still getting what? Bigger. Everybody clear about that? I mean, if you take 100 and divide by 5, it's 20. If you take 1,000 and divide by 5, it's going to be 200. If you take 10,000 and divide by 5, it's going to be 2,000. Everybody with me? So that dividing by 5 is slowing it down, but it's still getting what? Bigger. So did you get a number answer or did you get an infinity answer? You got a what? An infinity answer. So does this graph have a horizontal asymptote? Yes or no? No. That would be your proof that it doesn't. Okay? Just because it's a rational function doesn't mean you're necessarily going to have a horizontal asymptote. It means you might, but it doesn't mean you will. Now, in your mind, I'm going to show you one in a minute that you have to be real careful about when it's not algebraic. Do you see if this were negative infinity? It wouldn't be any different. This would still go to 0. This would still be that, and that would still be that. But 2 times a negative number would be a what? Negative infinity, wouldn't it? But that's still not a what? Number answer. So I still wouldn't have what? A horizontal asymptote. But you need to at least try it with positive infinity and with negative infinity. Because sometimes it's going to be different. I'll show you one in a second. All right, you try one more for me. And then I'll show you this one that's a little strange. What if instead I said, does this graph have a horizontal asymptote? Check that one for me. So 2x plus 1 over 5x cubed minus 3.
This stage, if you can make it bad, I might go on first I could ask.
All right, this time what did everything get divided by? X what? Cubed, the biggest power in the denominator. So you've got a 2x over an x cubed, you've got a 1 over an x cubed, you've got a 5x cubed over an x cubed, and you've got a 3 over an x cubed. So does everybody understand how I'm deciding what to divide every term by? It's the variable to the highest power in the denominator. So when I clean that up a little bit, what does 2x over x cubed simplify into? 2 over what? X squared. 1 over x cubed won't simplify. What does this simplify into? 5. And that one won't simplify. Now, what happens when this denominator is getting bigger and bigger? When you square it, it just gets bigger faster, doesn't it? So what happens to 2 over x squared? What does it go to? 0. You understand that 1 over x cubed, when that bottom's getting bigger and you cube it, just gets bigger faster. So that's also going to go to what? 0. What's the limit of a constant? Give me that constant. And again, that's going to be another 0. So what do I get for the answer? 0 divided by 5 is just 0. Did you get a number?
Yes.
Yeah. So what's your horizontal asymptote on that number 3 graph? Y equals what? 0 is a horizontal asymptote. So when you get a number answer, then y equals that number that you got as your horizontal asymptote. Now, if I change this to negative infinity, it's not going to change anything, is it? That's still going to go to 0. It's going to be a negative number, like a negative 0.1, then negative 0.01, then negative. It's still getting closer to 0, but it's getting closer to 0 from the left side. But let me show you one where that's not the case. All right. What if it was not a rational function? I don't have a polynomial over another polynomial. All right. What if instead I had something like, let's do that one. That's an easy one. One over 1 plus e to the negative x. Now this time my little technique, my little trick's not going to work. So I've got to take the limit of 1 over 1 plus e to the negative x as x approaches infinity. Now, you'll have a scientific calculator. So get your calculator out and let's start plugging some numbers in there. What if x is 10? So that's going to be 1 over 1 plus e to the negative 10. So go see what you get when you get that one. And then round it off for me if you need to round it off. So if I do e to the negative 10, and then add 1 to that, don't you get like 1.00000454? What happens when you take 1 and divide by that? What do you get about? I've got 1 over 1.00000454. What's that about? Isn't that about 1? All right, put 100 in there then. All right, so I've got to take e, and I've got to raise it to the negative 100 because there's a negative in front of this x. All right. And then add 1 to that. Get about what? Don't you get about 1? What if you did 1,000? When you get about what?
1.
What's it like this is? 1. Did you get a number answer? Then what's a horizontal asymptote?
Y equals 1.
Well, now look what happens when you do this. Change from positive infinity to negative infinity down. instead of 10, 100, and 1,000, I've got negative 10, negative 100, and negative 1,000. Now what's gonna happen when you put a negative 10, what's the opposite of a negative 10 gonna be? Positive 10, isn't it? So I'm gonna have e to the 10th, and then I'm gonna add 1, and I'm gonna do 1 divided by that answer, and I get about 0.0000045. What happens if you put a negative 100 in there? Well, the opposite of the negative 100 is a positive 100. So when I do e to the 100, get a ridiculously big number, and then I add 1 to it, and then I do 1 divided by that, what's that going to round to? Some really like ridiculously, everybody with me? What's happening here? This isn't going to 1, what's this going to? 0. I've got 2 horizontal asymptotes, and it changed when I approached positive infinity than when I approached what? Negative infinity. So when you're asked to find horizontal asymptotes, you need to check them both, especially when you've got like a trig or an e or a log thing going on. Algebraically, it doesn't usually make a difference, but I double check it just to see if there wasn't some weird glitch. So does everybody understand how I want you to check the horizontal asymptotes? Are we okay? All right. Let's do this.